All right, here's a formula for you. After I write the title here, 2-7. So this is the last lesson for the test. Nothing else after this. Formulas and literal equations. All right, so this whole chapter has been on equations. And so we're going to finish it off with what we call literal equations, which are basically formulas. Okay, a lot of literal equations are also formulas, and almost all formulas are literal equations, so that's why we can group them up together. All right, here's the first formula, and I want to see if you guys know what this formula is about. So D equals RT. Jensen, what's that about? Distance is equal to R. Yeah, what's R stand for? It could be replaced with something else, but not radius, rate. So here I'll give you a key. D equals distance. R equals rate, which for us a lot of times just means speed. And then T equals time. So your distance, rate, which is your speed, and time. So if you can give me your speed, and you can give me how long it took, how long you were going at that speed, I can give you the distance. That's the whole formula. Nice, simple distance. Okay. Let's go with an example here. Give me a speed. Let's talk about driving. Okay, driving. Give me a speed. Yes, ma'am?
60 miles per hour.
All right, 60 miles per hour. So we're going to say R is 60 miles per hour, not 6. Okay, and give me a time. How long was this? And we'll go with hours. Go with time in hours. 5 hours. Okay, 60 miles per hour for 5 hours would give me how far of a distance? 300. You guys get how a formula works? You put in what you know, and then you get what you don't know right away. So I knew 60 miles per hour. I knew 5 hours. That gives me 60 miles, or watch, 300 miles. Guys, this is a good formula, but does it really work?
Yes.
Think about it. Does it really work? Is it really accurate? Okay, I'm driving in the car, and I'm making a road trip, right? Because 5 hours is a long time to drive. But how am I actually driving? Think of my speedometer. How's it going? Is it stationary at?
Yes.
If you're on cruise control, it's more stationary. But have you ever seen cruise control speedometers? They do this.
No, they don't.
You know why? It does. But you know why? Because sometimes you go up a hill and your car doesn't know it's going up a hill until it feels that, and then it picks up the speed. So for a little bit it went down, and then it went back up, and then managed it. And then sometimes your car is going down a hill, and so it doesn't notice that until, oh wait, we're going down a hill, slow it down, and now we're back to speed. So your speedometer is doing this the whole time. Like that. So is it always going at 60 miles per hour exactly? No, it's close, and you can say like average speed, but is it always going perfectly 60 miles? No, it might be like 60.05 average, which is not that far off, but you're driving for 5 hours straight. Does that always happen? I'm driving down a road. I'm driving for 2 hours at 60 miles per hour. Pretty close. What happens sometimes?
Stoplight.
If you're driving 60 miles per hour, you're going to have a stoplight necessarily. You're probably on the highway, so you're going to have traffic, a collision, bad drivers, a slow driver. So you got to move. So this changes. Guys, this is if all things were perfect, this is what happens. But are all things perfect in our world? No, they're not. So how are you going to handle the imperfections of the world? Ready, guys? It's a little tease for another class. This is algebra. When you want to get all those imperfections added in there and accounted for, that's calculus.
Yeah.
Dun, dun, dun. That's why I tease for calculus. All right, anyway, we're not doing calculus. Huh?
Calculus hard.
No, listen, Betsy, if you took calculus today, yes, it would be very, very difficult. Good luck. If you took it in 3 years, you'd be ready for it.
I could take it.
You don't have to take it. You can take pre-calculus. Pre-calculus. Yeah, that's part of geometry. So yes, you'll take it next year. It seems like it's hard, but when you do more and more of it, you realize it's not that bad. And let me give you an example. I'll go a little bit into trig this year. A little bit into trig. And when you first look at it, It's a little bit of algebra, yep. When you look at it, you're just going to be like, oh, like all these words and concepts. And then after a while, I kind of get it. And then, oh, I get this. It just takes time. And some more than others, and that's okay. All right, but let's go back to this formula here. D equals RT. Okay, which variable is all by itself? Which variable is all by itself? Yes, John. Distance, right? What if I wanted to have a different variable in this equation all by itself? Well, can I do that? Pick which one you want to isolate. Which one you pick? Yes. Sorry? Rate. Okay, I want to get rate by itself. Is it by itself right now? No, but you can get it by itself by solving for R. So here I'm going to put solve for, that's hard to do, solve for R. Which I almost wanted to write once. Okay, solve for R. Okay, I want to get R by itself, so this is the process I go through. What's happening to R? It's being multiplied by T. What undoes that multiplication of T? So I'm going to divide both sides by T. Both sides get divided by T. And what happens to these T's? And I'm left with D over T equals R. So is R by itself? So I did solve for R, and now I get this equation right here. Okay, Mr. A, is this equation completely different from the original equation? No, it's just, we call it rewritten, rearranged. It's just arranged differently. And you're like, I don't know about that because that's that and that's all that. So you remember the numbers we dealt with last time? 360 and 5? Does it fit in this equation?
Yeah.
Okay, what was the distance? What was the time? It was 5 hours. And then what was the rate?
60.
So do they fit where they were in the original equation? Yep, they're right there. So did we alter the equation in a non-recognizable way? That means did we just change it completely? Like, here's a different equation now. It's the same equation, it just got rearranged. And so that's basically what we're doing this lesson, but not with that type of equation. We're dealing with these type of equations. Ready? Can somebody tell me what this equation refers to, or this formula refers to? Peter? 9.
It refers to Fahrenheit and Celsius.
Good. It refers to Fahrenheit temperatures and Celsius temperatures. Okay? How many of you are good at Fahrenheit? Like if I say 100 degrees Fahrenheit, you're like, that's really hot. You guys okay with that? Or 20 degrees Fahrenheit, that's pretty cold. Okay. How many of you are good with Celsius temperatures? Like if I said that's 20 degrees Celsius, you're like, oh wow, yeah, that's. Does anyone know? For me it's mild and it kind of depends on you. What about 90 degrees Celsius? Yeah. Good luck. Yeah, you're dead. You might be dead, yes. Okay, so some of you are good with it, some of you are kind of like, but it's those in-between numbers. Like if I said 100 degrees Celsius.
You're dead.
Yeah, if the temperature around us, we'd be boiled. That's boiling temperature of water. Like if we were water, the temperature is 100 degrees Celsius. Yeah, you're in a bad position. Okay, someone give me a Celsius temperature. Nothing too extreme. Just throw out a Celsius temperature. Murphy? 40. All right, 40 degrees Celsius. All right, how many degrees Fahrenheit is that? Give me a guess.
70.
75.
Okay, so I got 70, 100, 80, 70, 75. Okay, all right. Let's figure out what that actually is. Okay, so in this formula right here, do I know the Fahrenheit temperature? Was I given that info? No, that's what we're trying to find. Do I know the Celsius temperature? Yes, we said it's 40. So here, 9/5 times 40 plus 32. And that's going to equal my whatever temperature it is in Fahrenheit. Okay, so what do I have to deal with first? So this, you're not doing this on your homework, but I do want to give you like why we would even want to do this. But what do you do first here? Yeah, multiply, right? 9/5 times 40. And that's nice because you can cancel. So I'm left with 72 plus 32 equals Fahrenheit. So what's the Fahrenheit temperature? 1 104. So 40 degrees Celsius, what do you guys think? It's 40 degrees Celsius outside. Is that possible here?
Yeah.
Maybe.
I think so. Like back in California, the temperature where I was at, a little bit more inland from the coast, we would get 104 days, which is awful.
Attention, please. Please do not allow the students to go up on the main soccer field today due to a game.
All right, so yeah, stay on the lower field. Okay, 104 was a hotter summer day, but my highest temp ever experienced by me personally was 115.
Oh my God.
Okay, so this is the scenario, guys. It's 115. It's hot, but it's not a humid heat. It's a dry heat. So as long as your AC is working, you should be okay. But guess what happens at 115?
Your AC goes out.
Well, everyone is using their AC, and then power goes out. So we have rolling blackouts. When I was growing up as a teen, when that actually happened, we were having what we called an energy crisis, and it was actually corruption. They're keeping energy so that the energy goes up, and people don't like that. People vote differently. It was bad. So anyway, we had bad situation there. No AC, 115 degrees, and what my brother and I decided to do, because we were young, like let's go play basketball in the shade. We have this court in the shade. Let's just waste the time. So it's hot, you're sweating a lot. But I remember my brother. He's 3.5 years older than me. He was more aggressive with how he played and how he interacted. So we were playing against some guys at a park, and they're getting a, no punches, but I roll my ankle on some guy's foot because he steps underneath me when I'm trying to get a rebound. So I roll, and so my ankle is killing me right now. And then he's like, let's fight him. And I'm like, I'm not fighting anyone with a busted ankle. So we were getting upset. And so what ended up happening that night, no AC still, kitchen had tile. So I remember sleeping on the ground in my kitchen next to the screen and having my foot elevated with the heat. So I had heat from the outside and I had heat from the inside. It was the worst night of my life. That's what I remember. Well, no, it wasn't the worst. It was one of the worst. It was the hottest night of my life. That's how not the worst. There were some worse nights, but 104 is not that bad. Okay. The whole point is this is reasonable here. Do you guys get 104 a lot? This summer I don't think we got 104. So maybe some of you, but okay. 40 degrees Celsius. How does that relate to Fahrenheit? Okay, it's pretty hot. Okay. Let's do this with this equation. You guys can keep that. I'm going to erase it because I'm going to use it again. I don't need this here. Okay, this formula, this literal equation is solved for Fahrenheit, F. You guys okay with that? I want to solve it for Celsius. I want to get C by itself. It's not, but can I get it there? And the answer to that is yes. Okay, somebody tell me what's happening to C first. Yes?
Getting multiplied by 9/5.
First getting multiplied by 9/5, and then added with 32. So how do you undo that? Jensen? Okay, what do you want to do first? So it's first being multiplied, then being added. So how do you undo that?
You divide.
Subtract. You want to deal with this first because you want to undo it. So I'm going to subtract 32 from both sides. But I have a question, and it's critical. Are you allowed to subtract the same thing from both sides of an equation? Why? What property? You may state it now. Not quite, but you're allowed to say it. The subtraction property of equality. I'm allowed to do this. Okay, so this is what I'm left with. F minus 32 equals 9/5 C. Because these 32's canceled out. Okay, great. Is C by itself?
No.
Now, Jensen, what do I do?
Multiply by 5/9.
Okay, do you guys remember when you have a variable and a fraction? You can either divide by 9/5 or you can multiply by the reciprocal, which I think is easier. So I'm going to multiply both sides by 5/9. Is that okay? Yes or no? Is that okay?
Yes.
Somebody tell me why.
Because you want it to be.
Multiplication property of equality. Yes. Thank you, whoever said that. Okay, now what happens on the right side here? I'm left with C, yes. But here you must be careful. When you multiply both sides by something or divide both sides by something, I mean you have to multiply or divide both sides completely by something. This whole thing has to be multiplied by 5/9. So that's going to be my solution. I solve for C. Now, Mr. A, I don't agree with this parentheses putting. You just threw some parentheses in there. Do you guys remember the last numbers? We had 40 degrees Celsius was 104 Fahrenheit. Do you guys remember that problem we did? I erased it. Okay, does that fit in here? Does that make it true? Let's see. What was the Fahrenheit? 104. So here's my answer. I'm just going to circle it so we're not confused, but I want to check it. Minus 32 times 5/9 should give me what? I think it's 40. Okay, what's 104 minus 32? 72. What's 5/9 times 72? Well, what happens to this guy? What happens to that guy? What do I get?
40.
So is this the true rearrangement of the original equation? The answer to that is yes. If you only do 5/9 times f, you're not going to get the same numbers as we got before. So just be careful.
I plugged in 40 to see, and so I just said,
Yeah, 40. Yeah, 40 times that. 8 times 9, 72 plus 32. Yeah, 104. And it works, right, both ways? So are these two equations, or these two formulas, do they have the same results, is what I'm asking for. Yes. Is that a good thing? Yeah, because if they don't give me the same results, I'm just changing the equation, and that doesn't help me out. Okay, how many of you are fairly good at this? Like, you get what I'm doing. You get the process. You trust the process. Okay, yep.
So what we were trying to do is just to get the Celsius by itself?
Yep, that's all you want to do. Okay, let me give you another example for you guys to work out. Okay, here's the instructions. Solve for D. I want to solve for D. I want to get D by itself. And here's the equation. 3 times the quantity, D plus M, equals 8. What's my goal in this problem? I want to get D by itself. Is D by itself right now? No, it's surrounded by a couple things. What are those couple of things that it's surrounded by? First is being added with M and then being multiplied by 3. So how do I undo that? Yes, ma'am?
Could you subtract M?
So it's being added with M, then multiplied by 3. So what do I have to deal with first? Divide by 3. Divide by 3. And I mean both sides by 3. I don't mean one thing by 3. I mean both sides. That bar goes underneath everything on both sides. What's 3 over 3? 1, right? So I got rid of those 3's, and I'm left with D plus M equals 8/3. Okay, is D by itself yet? No. Nick, what do I do to both sides to get D by itself? Subtract M from both sides. And what am I left with? D equals 8/3 minus M. That's the solution for D. How many of you are okay with that? You're like, all right, I get this stuff. I just got to make sure I do it the right way. Yes, sir?
This also, I did 3D
Plus 3M?
plus 3M, and I subtracted 3M, so I got 8 minus 3M equals D.
Okay, so you did it this way. I think someone else said distributive property. So you get this right here? Okay, yes, that's accurate. But you're like, are these two solutions the same exact thing? Think about it. I'm asking a trick question. Is that the same as that?
yes.
Yeah.
Rachel, you had your hand for a while. Is it? Why? Because that doesn't look the same. That has 3 and 3. That one has 1 3. That one has 2 3s.
Because the 3 is being divided by the 8 and 3m, so it comes out 3m and
Yeah,
3.
good, Rachel. This right here, I don't expect you guys to really nail this down until a couple more months. And if you guys get it now, that's even better. Okay, here, isn't 8 minus 3m being divided by 3? So that really, this is what it means. That 8 is being divided by 3, and negative 3m is being divided by 3. And that's shown right here. So either one's good. Either one's good. They're the same thing. But if you can understand why they're the same, even better. But not yet if you can't. Okay, yes, sir. Yes. Mm-hmm. Okay, Jensen. Yes, we have done this before. So is this really a brand new concept, like we're just doing something radically different for this lesson? No, we're just solving for equations that have more than one variable. Okay, yes ma'am. I'll go here.
Keep it in an improper fraction form, or does it matter?
You could change it to your proper or your mixed number, but you don't have to. Yeah, in Algebra 1, you do a lot with improper. So I'm not even going to bring up improper as much. But yeah, it's a good question.
If 8 were a 6, would you want us to change it to 2?
Yes, it would be, if this were 6, 6 over 3 is 2 minus m. Yes, simplify that. If it could become a whole number or an integer, yeah, you need to simplify that, but that's okay for now. Yes, sir.
So you just don't do 8 divided by 3 because that's just like hard.
You could. I mean, 2 and 2/3.
I got like 2 points.
Oh, 6 repeating minus m. Yeah, I wouldn't. Yeah, just leave it improper. Makes it, yeah, easier for you and I think more understandable. Well, more usable later on. Okay, let me give you another one. This one's the toughest one I've given. Solve for z. So the instructions will be clear. Solve for the indicated variable. In this case, it's z. And here's the equation. 12z minus a equals 3z plus 7a. All right, so here's my equation. I'm trying to get what by itself? Z. But what do you notice about this equation and the other two equations? Or the other many equations that we dealt with today?
This is the first one with the z on both sides.
Yeah, z's on both sides. Not only z on both sides, but we also have a. Oh, man, I'm just throwing a bunch of stuff at you. What do you think you might want to try out? So I want to get your feedback. What do you think you might want to try? Betsy? I see that hand.
Okay.
Just what do you think?
Would you, hold on.
I'm trying to draw it out.
Would you add 12 to those? Would you subtract 3? Divide.
You had it. Okay, you said subtract 3z from both sides. Okay, your goal, before you start solving for z, why don't you get z in one spot first? Get z in one spot. So you can subtract 3z from both sides, or you can subtract 12z from both sides. Which one do you think might be easier? 3z. I think subtracting 3z from both sides would be nice.
Okay, but I did like the a first.
Yeah. Are you allowed to add a to both sides first? Yeah, of course, yes. And we're going to get the same answer if we both do it correctly. Okay, question.
Would it be wrong if you subtracted 7a from both sides?
Nope. You could see. Here's the cool part. In this problem, I'm looking at maybe 4 ways at least that you can work it out. So we're doing it one way, and you can do it a different way as long as you use those properties of equality. If you do that, you're fine. Okay. But here I have a here and a over there. So what can you do with the a's? Yes, ma'am.
You would add a to 7a.
You can add a to both sides, and that's allowed. So I get 9z equals 8a. Okay, is z all by itself?
Yes.
No. So how do I do that, Caroline?
Divide 9 by on the side.
Divide both sides by 9, and I get z equals 8a over 9. That's one way to write my answer. Does anyone know another way I can write my answer? Hint, hint, quiz, / it. Yeah, this will help you or hurt you or do nothing for you. Why?
Would it be 8 over 9a?
8/9 a. these are the same value right here. Good. Yes, sir?
So, like, me and Michael like to do the same way, but
Oh.
I did minus 7a from both sides instead of plus 1a from both sides, and so I got negative 8a equals negative za, and I got the same answer.
Oh, so you got negative 8a equals negative 9z?
Yes.
Mm-hmm.
Will
And
it
then,
work every time?
yes, every time it can work. And then you get positives, so you still get z. And then here, what's negative 8a over negative 9? Positive 8a over 9.
Okay.
It has to work every time, yep. And that's beyond me. There are other ways to work it out too, but we'll let these go. Yes?
I didn't write it this way, but couldn't you write it 8 over 9?
8 over 9. Okay, good question. So this a right here, in both of these answers, is always in a numerator.
Right.
So here it's in the numerator, and even here it's times a over 1. So keep it in the numerator. If you put it down here, it goes in the denominator. But yeah, that's a good question. Okay. Now it's time for me to see if you guys get it on your own. On page 61, where it says try these, just do number 1. It was funny, the last class, they're like, Mr. A, what do we do? I'm like, did you read the instructions? Pause for reading. Oh. Okay, so read the instructions. Number 1 on try these. Solve for x. Does anyone know what that formula is about?
Oh, I've seen this.
Yeah, you have.
Mx plus b, that's identical?
Wait.
Something about a line
Oh, it's
on a
slow.
graph. Slope. Slope-intercept form. Slope-intercept form. You'll see this soon. Yeah, but we're not dealing with the slope. We're just dealing get x by itself. Sorry?
I never learned that, by the way.
That's okay. We have another year to do.
The entire time y'all learned that, not sick.
Oh, okay. That's okay. Michael, we're going to go over it again. We'll go over it again. How could you get sick? Okay, no, that's okay. It happens. And maybe you were here and you're like, I still don't get it. That's okay. We'll get it this year. And then if you don't get it this year, we'll get it next year. Okay, we'll go over it again and again until you finally get it. Okay, what's happening to x, Alyssa? Give me the 2 things happening to x. First, multiplied by m, and then added by b. So how do I undo that? Okay, first it was multiplied, then it was added. So what do I deal with first? Subtract b from both sides. Do you guys notice that y and b are not like terms? You guys know that? So then you don't combine them, you just put y minus b. You can't do anything with them. Equals mx. Okay, so what's happening to x? Emma Grace.
It's being multiplied.
So what undoes the multiplication? Okay, and I mean divide both sides by m. Both sides by m. So what happens to those m's? Get canceled out. I'm left with y minus b over m. Equals x. Yeah, you can fit that. That's good. Equals x. How many of you got that one? Nice. How many of you want a tougher one? Good, I see those hands.
Me.
All right, let me do something real quick because some people get confused with this. All right. Here's a little diagram. Here's a little geometry for you. What shape is that? What? It starts with a T, so I'll give you that. It's a trapezoid, okay? Everyone good? That's a trapezoid? Okay. So here, I'm trying to find the area of this trapezoid. There's a formula for area of a trapezoid, and it's this. And I wish I had more time to go over it, but it's basically, it's A, which is area, stands for 1/2 the height. So the height would be this right here, whatever that height is from this side to that side, times this base plus this base. Now, the way I wrote it is not clear. Do you notice this base is longer than that base? Do you guys notice that? Okay, you really think I should use the same letter for both of them if they're different?
Yes.
I shouldn't, because this one is, let's say this is 8 and this is 6. Are these really the same thing? No. So I don't want to use B and B for both of them. I do want to distinguish them. But they're both bases. They're both bases. So I call this a base and I call that a base. So, yeah, here's what I would do if I had like an ability to do this. Can I rotate this? And would it still be the same figure? But then that would be the bottom, that would be the top. So base is actually something else. But how do I distinguish between this base and that base? This is how I do it. I put a subscript. Does anyone know what a subscript? Yes. Something written under another thing. Subscript of 1, subscript of 2. Base 1, base 2. Now, are these two the same thing now? No. They're both bases, but one's a base of one part and one's a base of another part. So you guys see how I put that? No, I'm just explaining the next problem because I'm going to give you the next problem in just a moment. Which you probably can see in your try these. Okay, question, yes?
Yeah, if we were ever to do that, wouldn't we then have to put a subscript on like the 8 and the 6 or something like that, or like on next to the line so you know which one's which?
You know, this is the cool part. Ready? Ready, Michael? What's going on between B sub 1 and B sub 2? Adding. So does it matter which one I put for B1, B2? No. And that's the cool part. That's the cool part about this.
What if it was dividing? Then it wouldn't matter.
It would matter. Yes, you're right. But not in this one. No. And I'm trying to think of a formula where you would do that. No. It's when you can separate them like that, which is cool, you could usually flop them, switch them up a little bit. Flip flop them. Why?
Are we going to do Chinese number 6? Is that how you're doing
Whoa. Yes, number 6.
Well, this looks familiar.
Yeah, I hope it does. What are you trying to solve for in that problem? B sub 1. So I'm B sub 1 by itself, not B sub 2, and I don't want to combine B sub 1 and B sub 2 because they may not be the same. They won't be the same. They can't be the same. All right. I'll give you maybe another minute, and then I'm going to start asking people questions. Yes, please?
Are you supposed to add B sub skip 3, but wouldn't that be changing?
Oh, yeah.
To get B1 all
Yes, so you can't combine these together. Yeah, so keep them separate. And get B sub 1 by itself. Okay, let me help you out with this one because you could be a little bit stuck, especially on this little part right here. So let me help you out. Okay, what's happening to B sub 1? Jensen. Added with B sub 2, and then? Multiplied by H and a half. Or it's multiplied by 1/2 H. Whichever way you want to say it. Okay, so what do I have to deal with first? Yes?
I may be wrong, but I divided by 1/2 H.
Okay, you're allowed to divide by 1/2 H. That is correct. You could do that, but that gets tricky when you're dividing by a variable and a number next to it. So let me help you out on this problem to give you like a little help on these kind of problems. I'm going to divide both sides by H. Divide both sides by H. Did I forget about the 1/2? No, I'm just taking it one step at a time. Just divide both sides by H. What happens to the H's? On the right side, they cancel. So I'm left with 1/2 B sub 1 plus B sub 2 equals A over H. Now what do I do? Yes?
Multiply each side by 2.
Good. I multiply both sides by 2. Well, mister, I thought these were being multiplied. They are, but what can you do to undo multiplication of a fraction? Yeah, I'm going to multiply both sides by 2. Sorry? Yeah, what's the reciprocal 1/2? 2 over 1. Okay, so here I'm left with 2A over H equals b sub 1 plus b sub 2. So how do I undo the addition here? Yes, sir? Subtract b sub 2 from both sides. And here's what I'm left with. 2a over h minus b sub 2 equals b sub 1.
I got a minus b sub 2 multiplied by 2.
So you got this whole thing?
Yes, but I put the 2 next to the b2.
Gotcha. Okay. Here, when I went through my steps here, I chose to divide by h first because I want to take it just one little step at a time. It's easier to digest. Did you do it by 1/2 h? Did you divide both sides by 1/2 h? Or how did you do it?
I actually subtracted b1 first.
Okay, so that's going to be the issue because should you subtract b sub 1 first?
Oh, no.
Or b sub 2, should you subtract that first? No, because that's happening. You're reversing it. Deal with this first, then deal with that. So that may have thrown you off. Okay, John?
So I did when we were multiplying by 2,
Mm-hmm.
I did a h and then times 2.
Mm-hmm. Right here?
So is that the same thing as 2a
Mhm.
over h? Okay, so if I put h times 2
h times 2.
minus,
Yes. You can technically do this. So a over h times like this
yes,
minus b sub 2. Yeah, and then maybe someone asked me, I think it's maybe the last class, should I put a dot or should I put them together? Put them together. So like combine these together.
okay.
So you get 2a over h minus b sub 2. Which same thing. Yes, sir?
Well, we have to satisfy this with one.
Yes, this will be the hardest one.
Would it be wrong if I just put
Nope. No, I'll probably just scratch out the multiplication sign. Well, yeah. All right, next one. Ooh. This is the last one. If you could do this one, you're on a good path. Okay, we'll go to page 61, same thing. Do number 5. Number 5, if you can handle this one, good path. Solve for m. Don't get overwhelmed by the problem just by looking at it like, oh my goodness, what's happening? No, take it one step at a time. That's q equals m minus 10x divided by w. And I'm trying to get m by itself. Let's take it one step at a time. Find the variable. If you can find the variable, you're on a good path. What's happening to that variable first, second, third, fourth? Then undo that. That's the answer. If you can't see it, that's fine. All right, what did I do first in my work? Why?
You divided both sides, or you multiplied both sides by w.
All right, I got multiply both sides by w. That gave me WQ equals m minus 10x. What did I do next? If you can see it, that's kind of hard.
I can see it.
Sarah?
You added 10x to both sides, and then the negative 10x and the positive 10x cancel out.
Oh, what do I get? What's my final answer here?
WQ plus 10x equals m.
Yes, WQ plus 10x equals m.
Isn't it okay if you just put w times q?
Yeah, and that's the same one. So you have w times q. Yes, you can, but you can take that sign away.
I got WQ over X plus 10.
Oh, because I think you divided by x on both sides. Okay, when did you divide by x on both sides? Was it here? First step? Sorry, I should say. Was it your first step?
I did it times W.
Mhm.
I got rid of W, and so W times Q equals M minus 10X, and I divided by X.
Okay, so when you divided by x, everything has to be divided by x. So that means you would have ended up with WQ over x equals m minus 10x over x. So you actually, then you'd get m over x, which is, so you gotta, what are you trying to get by itself? M?
Yeah, so when I did that, I put it as WQ over X equals M minus 10.
Yeah, so you didn't have the bar. You had it like that. And then these canceled.
Yeah.
But did you actually divide both sides completely by X? No, so yeah, that's what I'm trying to point out. And that's that. I'm glad you're doing that because now I hope you guys know. When I say divide both sides by something, I mean both sides. Like the whole thing gets divided by X. That means this gets all of it by X. But that wouldn't help it because you'd either be left with m over x minus 10. Oh wait, that's not it. You'd get this, which now you're getting. There's more. It's bogging it down.
After you just add 10X.
Add 10x.
Mm-hmm.
Mm-hmm. Good. Yes.
Couldn't you subtract or add negative 10x to each side? Or would that not work?
Add. Oh, the first step?
Yeah.
No, because what's happening to m first? It's being subtracted, but then it's being divided. So you have to deal with that division first. Okay. Yes, sir. What?
It wouldn't be wrong if I put Q.
W?
QW.
No. There actually here are your options for how to write it. Okay, this is what I got. You, I think, may have gotten this. Some of you may have gotten this. Some of you may have gotten that. Minus that little skew mark.
There's two more ends.
You could do
What?
n equals.
You could do all of these reversed.
And then you could do Q with the dot.
You could do.
Okay.
Please don't mess up, so sorry. When I drop Swivel's marker, I'm so sorry. It tends to corrupt the video and then it erases it. It says can't save it. I'm like, no, Swivel. Thank you, Swivel. I'm so sorry. Yes, I'm so sorry.
Strong as city.
Peter, is something wrong with that? Okay, good. All right. Does anyone know why you're allowed to write it all these different ways? There's really two properties going on there. Commutative property, whether it be with addition, like you're switching the addition around, or you're switching the multiplication around. And then that other one that Murphy brought up, you could say m equals all that. That's the reflexive property. All you're doing is like switching it around. So yeah, 8 ways to write it. You pick one of those 8. So you know how many answers there are to these problems? There's 8 answers. Find one of them.
No, wait. There's
Okay.
10 because you didn't do the.
Oh, the dots. Oh, so there's probably like 20 now because now you're dot. Yeah, there's a lot.
Plus you can add the ones.
Yeah. So there are dozens of answers. You need to find one of them. See, doesn't it sound better? There's only one answer. You must find it. No, dozens. Find it. Okay, homework. You can start a little bit. Numbers 2 to 26 even. And that's pages 51 to 52.
What time is it?
Oh, goodbye, Sylvia.